All right, take 15. ICM Video Thing, my project. It's Corinne, the better one. I chose problem 4. A hypothetical square grows so that the length of its diagonals are increasing at a rate of 8 meters per minute. How fast is the area of the square increasing when the diagonals are 11 meters each? And I accidentally wrote that wrong. That's why it's ugly. Okay. All right, here's my work. So I started out by drawing a square that's increasing on all sides. But in this problem, it is 11 meters. That's what the x is. And then the derivative of x is 8 meters per minute. And so the equation of area is 2x. And then you would multiply that by the derivative of x. So your equation to get the answer would just be a equals 2 times 11 times 8, which is just 176 meters squared per minute. Okay. You just have to remember to multiply x by the derivative, because that's kind of confusing. It doesn't make any sense, but it's okay. All right, this is my problem that I created, and it's really dumb, but it's fine. She's cool. All right, a person is standing 300 feet away from a launch pad, which is way too close, you will die, to observe a rocket launch. The rocket launches from a pad and maintains a velocity of 500 feet per second. How fast is the observer to rocket distance changing when the rocket is 1,300 feet from the ground, assuming it is a right triangle? Okay, so first off, you start by putting in your drawing, and so you can see that 300 feet is unchanging because the person observing is not moving any closer or farther away from the rocket, but the rocket is moving up higher, so the 1,300 does change, but in this problem we are looking at 1,300. Okay, so you're going to start off by, you don't know x in this equation, so you're starting off by you're doing Pythagorean theorem to find x, and I got this really stupid number because my things didn't work. It's really ugly, but it's 1,431 and 0.78 roughly, and y equals 1,300 feet. So you know the derivative of x is 500, and you're trying to find the derivative of y. So you're going to do the equation x squared equals y squared plus, in this case, 500 squared. But 500 squared is a constant, so it's just plus 0. And then you find the derivative of x squared and y squared with, considering t, I think is how you would say that. Okay. And then, so they would both have like primes multiplied by them. So it would be 2x times the derivative of x and 2y times the derivative of y. So then you would just put your numbers in and you would just plug them in. So it would be 2 times the really ugly x times 500 equals 2 times 1,300 times the derivative of y. And to get the derivative of y alone, you would do 2 times 1,300 divided by your other numbers that are on the top. And then you would get, if you like simplify everything, you would get this really ugly number as your answer. So it would be 550.68 feet per second at 1,300 feet. All right, this has been fun.